What's going on, guys? It's the Unhinged Engineer here, and today I thought that I would take my entire 4-year bachelor's in aerospace engineering and try to condense it as tightly as possible so it could fit with you guys are really enjoying the education content. And I thought I would take everything I learned in my 4 years in college and try to condense it down as tightly as possible for all of our TikTok attention spans. So without further ado, let's get right into my entire aerospace engineering degree in hopefully less than 15 minutes. Bottom line up front, this is a summary of my entire degree in one slide. Freshman year on the left, going to sophomore, junior, and senior. I won't spend too long on this slide, but just to call out, right? You can see on the left, like everything is super general. We're barely going to talk about this stuff because it's pretty straightforward. A lot of you may have done it if you're still in high school. And then sophomore year, it's still pretty general, but you're starting to slowly kind of hone in on your specific type of engineering. Freshman year is like general math and science, just kind of for anybody. Sophomore year is taking those things, getting a little bit more advanced and applying it to actual engineering systems. Junior year is where you really get into your major. So again, that's obviously aerospace for me, but like in general, if it's mechanical or chemical or other kinds of engineering, this is where you really hit the gas on your major specific classes. And then senior year is kind of the falling action there, right? Like junior year is usually the big crunch. Senior year is kind of crossing T's, dotting I's, applying things to some cool projects, learning like slightly more advanced things, actually doing some electives, which I'll talk about here. I have those denoted with E. Not as intense as junior year, but honestly more fun in my experience. So one thing I will say is that I went to a large state school in America. And so I looked at like kind of my rivals from back in the day, and it seems like most big state schools, and I would even argue most colleges in the US at least, follow pretty similar suggested academic plans. So obviously like mileage will vary on this exact prescription of what classes you're going to take, but not that much, especially for a major as kind of focused on one field, which is aerospace engineering. I've talked about some nomenclature around whether aerospace is specific or general, whatever. Nonetheless, most of the degree plans do seem to follow like a pretty similar path. So freshman year, we're going to spend very little time on this because it's pretty straightforward, and you may have taken even some of these classes in high school. Right? Only things worth calling out here, like Calc 1, Intro to Calculus, Calc 2, kind of series and sequences, which will be useful in certain classes depending on what you decide to specialize in. Physics, so the one thing I will note here is you may have taken physics in a purely algebra-based way, but what physics 1 and 2 in college will likely be is actually doing a calculus-based approach to either classical mechanics in the physics 1 case or classical E&M in the physics 2 case. So that may be new if you're actually applying calculus to these fields rather than just doing it with algebra. Now, if I remember correctly from my own experience, I actually remember the calculus way of learning things being a bit easier and more intuitive than the algebra-based way of doing things. Like lots of non-STEM or non-engineering majors will only ever do physics in this algebra-centric way. I really enjoyed the calculus approach more. So that's worth calling out here. Other thing is like this engineering design class. If you're as unlucky as me, you'll probably have a generic class with a stupid name where they teach you how to put post-it notes on a whiteboard and draw a Gantt chart. So that's what engineering design was for me. One useful thing I did learn from this was actually a little bit of an intro to SolidWorks, but I would even say that was at a level of proficiency worth putting on your resume. I did wind up taking a better certification course later on that I don't have listed here, just for kind of an intro to CAD if you've never really done it before. The engineering design class was useful for that, but everything else was kind of just busy work. Freshman year is a lot of that. Whatever. Let's move on. Sophomore year. Now we're getting a little bit more interesting. So intro to computer programming here. This isn't even at the level of data structures and algorithms. Like technically you could say this is stuff you're learning, but the most complicated data structure you're probably going to learn is a list, and the most complicated algorithm you're going to learn is probably a loop. So this is not very sophisticated class. But if you've never taken programming before, if you've never done any programming before, this is where you start. One thing that was nice about this is it's general enough that we had to choose between C++, MATLAB, and Python. I chose C++. I think that was a good decision based on some of the stuff I had to do later down the line in my career. But Python's obviously like the go-to in terms of a first language to really learn if you're really starting from square zero. Moving on to statics and strengths of materials. So this is a bit more advanced than classical mechanics, but things are actually not moving at all here, right? So you're really looking at static systems like a beam or a rod or some kind of frame or whatnot, even a pressure tank. Like if you have a tank where the gas inside has a certain pressure and then the gas outside, if that's open air, has a different one. All these things you're looking at kind of the stress and strain or even deformation on these rigid bodies based on whatever forces or torques you put on them. So now this does actually get pretty intense, and I did really enjoy this class. Like even though I'm not a structures guy, like if you watch this channel, you know I'm more into algorithms and programming, AI ML stuff, GNC. I'm not as much into the structural piece. I do remember this kind of foundational understanding of how physical bodies don't crumble into a million pieces, or when they do. This stuff was really good for that, and I enjoyed the class. Moving on to linear algebra. As you guys may know, I am a huge huge linear algebra fanboy. I think it's just as important as calculus and gets way less real estate within most degrees. But linear algebra, as we start to do some matrix math, you get a little bit fancier in terms of what applications you're using them for. Like I've said a million times, I really, really enjoy learning linear algebra, and that was kind of the bedrock of more so what I just described, like the algorithms part and the programming. 9 times out of 10, you're going to be doing vector operations, and so it's really good to know how matrices work and how they can make those computations more efficient. So moving on from that, ordinary and partial differential equations. If I remember correctly, I actually took a 3-credit class that was just ordinary differential equations and then had a 1-credit add-on for partial differential equations. My school did it weirdly, but effectively this is the differential equations class. And so you learn about how these equations work, how to model them, some of the fancy things you can do with like Laplace transformations, whatnot. This will be much, much more stressed in your later engineering classes. For almost every major, you're going to get more in depth than this goes, but this is just your intro to differential equations, which is typically omitted from the previous calc classes. Last one, I'll briefly touch on this. I was going to do an IT for aerospace minor at some point, and so this was like an intro to that. Once I started getting good programming jobs and realized this was unnecessary, I immediately dropped it. Like, it was a stupid waste of time. Guess I learned SQL, but never used it again. So, okay, semester 2 of sophomore year. So for one, with public speaking, that was during the pandemic, so it wasn't really a great class. Dynamics is taking some of the stuff you did in mechanics and even statics. Like, you do apply a lot of these concepts, especially to do with rotational motion and torques and whatnot, and you start moving things. You start moving particles, you start looking at moments of inertia and the different kinds of advanced dynamics modeling that will be used, again, much more further down the line in your education. Strength of materials lab was pretty much a more advanced version of the latter half of the statics and strength of materials thing. So one thing I will say is the material properties of whatever is under stress obviously matter a lot. So typically the way these kinds of classes will go will be, the beginning will kind of be like, assume any material. You're not really thinking about that yet. You're just thinking about the actual concepts of shear and stress and strain and modeling deformation, whatever. And then you'll get more into the actual materials themselves. And so this is just kind of an extension of that with a lab component. Vector calculus, really taking the differential equation stuff you did, gelling it together with the linear algebra you did to model stuff in like 3D or even higher dimensional spaces. Thermodynamics, I wound up taking a super basic version of thermodynamics. I didn't get into it as much as other mechanical or chemical engineers will get. I learned the fundamentals that I would need for stuff like aerodynamics, specifically aerodynamics 2, which we'll get to obviously. But yeah, thermodynamics was not my thing, so I'm not complaining about not having to go that much into it. So once we get through sophomore year, which is kind of like more sophisticated versions of the general stuff you did, but not quite honed in on your major yet, now we're getting to the good stuff. Now we're really starting to focus on aerospace specifically. So starting off with structures, really just taking all the stuff we just talked about from statics, objective materials, but now you're looking at wings and like the fuselage and any physical structure on the aircraft for different maneuvers or modes of operation for that aircraft. How do things start to bend? When do they start to break? Understanding concepts of factor of safety and when something might need reinforcement depending on the different forces you can expect. Yeah, aerospace structures. Simple enough. One thing I will note that's really cool is that you actually want wings to bend. Like, if wings were perfectly stiff and didn't flex at all when you're flying, that would actually be really bad for many reasons. So learning about how to account for some of that give and actually utilize it for more safety, not less, that was really cool. Anyway, we're pressed for time. Let's keep going. Astronautics, this is really just orbital mechanics, mostly Earth-centric, so we didn't get much into like lunar transfers or any of that crazy stuff. We did do some attitude control, like attitude determination and control things, but this was a pretty basic course that mostly focused on the orbital piece. And I say that as somebody who focused a lot more on the attitude stuff later on in their career. This was pretty much focused on the orbital part. Next, aerodynamics 1. This was honestly like just a really hard fluid mechanics class. So fluids are still going through pipes or funnels and thinking about Venturi tubes and the Bernoulli principle. Pretty straightforward fluid mechanics. I wouldn't even consider this aerodynamics as much yet, although we did start to look at like airfoils and wings and stuff. It was really just about understanding the concepts of fluid dynamics. And lastly, aerospace analysis. I guess not lastly, technical writing's there, but nobody cares. Aerospace analysis was really about mathematical tools in the context of aerospace problems. So a lot of stuff from the previous math classes we talked about, just wrapping it all in a neat little bow and applying it to some of the areas that I just discussed in the other classes. So really, really cool class, like really impacted me a lot as a student, but kind of an unsexy description. Like, it's really just hard math class focused on aerospace. Simple enough. And then technical writing, who cares? It was actually a pretty useful class, I should say. Like, learning how to write reports was good, but yeah. not the most flashy. Okay, semester 2 of junior year. I think I'm running out of time. We're gonna keep going. System dynamics and controls. This was probably the class where I realized I was the most interested in guidance, navigation, and control. The description for my university's like bulletin said it was mostly focused on vibrations. I think that's not actually correct. We did do a lot of frequency analysis, but we weren't like specifically focused on vibrations of physical bodies. I actually know some mechanical engineers took vibe classes more so than I did, but this was more so just about like understanding Bode plots and Nyquist criterions for stability, even like root locus methods, and using all these different analysis tools to actually come up with good controllers that give us the system behavior we want. Next one was advanced programming for aerospace. This was in theory supposed to teach us more about C++ within the context of aerospace. I don't know why they have Java and Ada listed there. There's mostly C++. You know, I would say like in hindsight, this wasn't really good enough to start writing flight software because there's lots of idiosyncrasies of how processors actually work that you need to understand to really write good, high-performing flight software. But it was better, like especially in terms of modeling and simulation area that I've spent a lot of my career in. So yeah, it was much better, and it really stressed some of the C++ concepts we had. Next one, aeronautics. So this is more just about aviation in general, like understanding what parts of an aircraft design factor into its range, factor into how high it can fly and at what speeds it can fly at a certain altitude, like performance envelopes, high G maneuvers and cool stuff with dogfighting or whatnot. This is really more so about aviation and specifically fixed wing aircraft. Okay, so as of right now, I have next aerodynamics 2. This is where we really start to get more into fluid mechanics as applied to aerodynamics. So you're doing some really more advanced stuff with like boundary layers on an airfoil that can account for drag, and you get like flow separation towards the back, which you can get vortices and modeling vortices and how much they affect performance. Like you're really getting more so into that part of aviation, and even a little bit into rotors and stators and like jet turbines and understanding how modes of propulsion on aircraft really work. We had a dedicated propulsion class later that would really stress that stuff, but this is where you're getting the basics of it in there, which was super cool. And obviously this wave motion and quantum physics class, like I don't even know what the hell the point of this was. It was all cocktail party science with like relativity and Einstein stuff that I have just never used. I mean, maybe like some of the optical pieces of it were useful for some of the things that I've done specifically, but we honestly didn't get into them enough for it to really stick because we were focused on like stupid hypothetical problems that you talk to other nerds about. So it wasn't really a very useful class. So first up for senior year, we have the capstone. This is really straightforward. Like it was 2 classes actually. In the first one, you would do like a preliminary design, write up a review, present your design to like other students and the professor, and then implement some feedback. Like pretty straightforward. I could make a whole rant about how capstones don't actually teach you the professional skills that they claim to, and usually they're just kind of a weird facsimile and a waste of everybody's time that could be better spent either A, on another technical course, or B, doing a damn internship. But either way, you know, this was our capstone. It is what it is. There were actually 4 options: fixed wing aircraft, rotorcraft, spacecraft, and autonomous vehicles. I chose autonomous vehicles, and the capstone itself was lame, but the elective I have at the bottom there was really, really cool, which I'll get to. So next was propulsion, which is really just taking some of the aerodynamics 2 stuff we learned about with like turbines and even like ramjets and scramjets and different kinds of air-breathing propulsion for aircraft, taking that to the extreme, really learning more about that, and then actually getting into some of the pieces with rockets, so like solid rocket fuel, like liquid oxidized fuel, whatever it's called. Yeah, the different kinds of propulsion that rockets use. I'm not much of a propulsion guy, but that class was okay. The professor was nuts, but the class was okay. Aircraft stability and control was really cool because it kind of took like some of the system dynamics things plus the aeronautics stuff we learned and like took it to the max in terms of actually applying it to real aircraft, whether that's something in a dogfight or some kind of bomber or even an airliner with people on it. Just understanding kind of how all the math we did is actually applied in the real world. Like this is a pattern you can clearly see where, you know, you're skewing more towards application towards the latter half of your degree. This is really, really cool. I feel like the description doesn't do it justice here. We learned a lot in that class, which was awesome. Okay, I have 2 electives here. So I did advanced control systems, which is pretty straightforward, you know, same kind of concepts that we did previously. We got a little bit into like model predictive control and nonlinear optimization, like a tiny bit, but those are really grad school topics that we just kind of scratched the surface of. So it was a cool class. I can talk the talk a little bit with some people who wound up getting their masters and whatnot, but it really wouldn't be until I actually start to use these concepts in the real world that I could understand and speak to them better. Last one was aerospace autonomy, which was really, really sick. Aerospace autonomy was an awesome class that taught us all about like, you know, some of the guidance, navigation, and control stuff, learning more about Kalman filters, particle filtering, like decision trees and other modes of autonomy, even applying AI/ML and deep learning to these problems. It was a pretty neat like special topics class. One of my favorite ones. We had an awesome professor semester, and everything was project-based. We also did some kind of one-off topics like ProNav, which is a missile guidance algorithm. So overall, it was a pretty cool class that taught us a ton. Don't sleep on electives. They can be really good opportunities. And then the last one. So second half of the capstone, pretty straightforward. Circuit design was honestly an intro to electrical engineering class. For some reason, aerospace engineers could take that as an elective, and it was pretty cool. I think I dropped it halfway through, if I remember correctly, but it was a cool class, and I learned a little bit more about, how circuits actually work that would be useful at my first job. That was more software engineering oriented. And then lastly, just the lab where you're doing goofy stuff in a wind tunnel, starting to understand, how to actually process data from like real tests. I'm a software guy, and so I don't really use this stuff very much, and I'm very okay with that. And then the writing lab was just the writing component associated with it, so not a big deal. Extra credit for the report. Okay, that is it. So we definitely failed this challenge. So I don't know what I'm gonna title the video now. I guess I'll still title it under 15 minutes, and I guess it'll just be a lie. So congratulations, you've been clickbaited. But regardless, I hope you enjoyed this video. It was fun to go all the way through my aerospace engineering degree in as short a time as I possibly could. Maybe someday I'll speed run this again and give it another try. But in the meantime, I hope you enjoyed this video. I'm the Unhinged Engineer. I make professional development content for other engineers like myself. So if you're interested in like interview skills, negotiation with potential employers, getting promoted, salaries, like all that actually important stuff for leading a career you really enjoy that they don't teach you in school, then this is the channel for you. I also make videos about aerospace engineering proper, which is what I am currently working in. So if you're interested in that, this is definitely a channel for you. Thanks a lot for watching. I will see you next time.